There are a couple of little special cases that we have to consider with the sine rule, cos rule, where it doesn't come out exactly as expected. This first one, for instance, is a sine rule because I've got my 30 and my 9, my known bone. I'll stick it in the sine rule formula. The only problem I have with that answer is I've got 62 degrees and this angle is clearly obtuse. A lot of the time they will make it very, very obvious, say it is to scale or point out that this is obtuse, which means your angle is too small at 62 degrees. Under this circumstance, what you have to do is actually minus that angle from 180. So the actual theta is going to be 180 minus that guy, 117.3. Now there's a full explanation of that coming in when we deal with obtuse angles or angles greater than 90 degrees, because there's a whole another realm of maths to explain why that is. But for now you need to know that if your angle is obtuse and you've got a sine rule question, sometimes you actually have to flip it to the opposite 180 minus the one you had. This other special case is when I can draw a known bone but I don't have another bone, and I also can't create one with angle sum of a triangle. So under this circumstance, what I do is I create a bone and I create a variable. Then I'm going to use the sine rule to solve for that variable. Once I've got that, I can angle sum of a triangle for this one, and then I can use the sine rule or the cos rule to find x. It's a lot of work, but that's how you would do it. Feel free to pause, and then I'll give you the solution. Now I've recorded theta here, I've stored it in my calculator because I'll reuse it for my next bit. Now because I restored every number in my calculator the whole way, I'm pretty happy with that answer. I'm also happy with that answer because this triangle with a 60 degrees here, the other angles should be similar to that and the sides would all be similar as well. Remember, an equilateral triangle would be 60, 60 and 60. All right, there you go.